This will be a very short video where I discuss the topic of inverse of matrix multiplication. I will restrict the discussion to square matrices, right? So matrices of the form A m by m. You can think of this matrix belongs to, for our discussion, let's say it belongs to real matrix, real numbers over m by m, which means that every entry Aij belongs to R, right? So every entry in the matrix A is a real number. So an example matrix would be 1, 2, 3, 4, right? So this matrix belongs to R of 2 cross 2. Okay, so yes. So the common mistakes the students usually makes, right? So when talking about inverses is that, let's say they see an expression like this: AB is equal to AC. Without thinking, they might write like this implies B is equal to C. But this is wrong, completely wrong. This is not true. This is not true for all matrices. Okay. You can only cancel out matrices of certain type with respect to matrix multiplication. So before talking about inverse of a matrix, so we need to know what an identity of a matrix multiplication is. So identity of a matrix multiplication, let's say, so identity matrix over of a square matrix of size m by m, it will look something like this, right? So all the elements in the diagonals are 1 and rest of the elements are 0. So in the last video I explained how matrix multiplication should be viewed as. For example, if you take I into A, you can write the matrix A as, let's say, m rows. Okay, so basically this first row selects the first row, right? 1 0 0, it's just a linear combination of all the rows, and the coefficient of R1 will be 1, rest of the elements are 0. So this will just give you the matrix R1, R2 up to Rm, which is nothing but the matrix A. Similarly, for column multiplication, multiplying I from the right hand side, A into I, you can conclude that, first you can think of the matrix A as the collection of m column vectors. Okay, and we have identity matrix in this side, right? So remaining elements are 0. So basically the column vector 1 will select the column 1 of the matrix A, and you will indeed get the matrix A in the right hand side. So I is the inverse of the matrix. Okay, so now we are asking the question whether there exists an inverse. For example, the question is, given A and m by m matrix A, there exists A inverse such that, A inverse also an m by n matrix such that A inverse into A is equal to I. Okay, so for what kind of matrices does inverse exist, and for what kind of matrices that does not exist? Okay, so for example, let me give you an example. Let's take a simple 2 by 2 matrix of type 1 0 0 0. Okay, so this matrix does not have any inverse. For example, for whatever the matrix you multiply, let's say take some arbitrary matrices of size ABCD, you will basically get, this matrix just selects the first row, right? So multiplying the first row with the matrix in the right hand side will simply give you the first row, and the second row is simply 0, completely 0. So you will just simply get the 0 for second row. So no matter what are the values of A or ABCD, you cannot turn this multiply with this matrix to get an identity matrix. Similarly, you can verify for right multiplication as well, right? So it's not true in general. And one more question: if you can find a matrix, you can find A inverse such that A inverse into A is equal to I, does that imply A into A inverse is also equal to I? Think about this. Matrix multiplication is not commutative, right? So we have to take some extra steps to actually prove that this is indeed true. If we can find the matrix A inverse such that A inverse into A is equal to I, we can actually prove that A into A inverse is also equal to I, but we have to prove it, right? So this is not an obvious answer. Okay, so why matrix multiplication is not commutative? Let me give you a simple example for that also, right? Consider the matrix 0 1 1 0 multiplied with the matrix, let's say 1 3 5 4. Okay, so if you multiply it from the left hand side, the matrix that you get is 5 4 1 3. They say, but if you multiply that same matrix to the right hand side of this matrix, what we will get? We will get simply 3 4 1 5. Right? It's a column multiplication. So this column selects the second column. Right? So this column selects the first column. Okay. So these are not true. Obviously, this matrix is not equal to this matrix. Right? So matrix multiplication is not commutative. So we will discuss. I will extend this discussion further in the next video. But before talking about how a matrix is, how an invertible matrix will look like, we need to discuss about elementary matrices. Be tuned for the next video. Thank you.